Hey everyone. Hello. Can you hear me fine? Volume okay? More? How about now? Better? Okay. Okay. Hey, welcome to another lecture of DSCI 511. In this lecture, we're going to learn about a lot of very important and also exciting stuff. If you remember, in the previous lectures, previous labs, we have discussed the concept of data types. So can someone briefly mention what a data type, what was the essence of a data type? It had two components, if you remember. So when we say that we have a list, what is the essence of a list? There's two components to it, right? There's the data that you store inside of that list, and also there are the operations that you're allowed to do on that particular data type. So for a list, for example, you have .append, you have .pop, and a lot of other methods that are specific to a list. However, for example, with a string, you do not have .append or .pop or something or anything like that, but you have other methods like split, like upper, lower, and methods like that. So with each particular data type, we have the data itself and the particular way that it's organized inside of that data type, and also the kind of operations that you're allowed to do or are defined for us to be able to do with that particular data. Now, today, we're going to take a peek into the inner workings of these data types, and we will learn how to define our own data types, because this is a central idea in what's called object-oriented programming. It means that you, in order to organize your data and define the operations that you want to do on that data, you define what's called objects. Objects are nothing but the collection or a bundling of functions and data together all in one place. For example, a list, when you define a list, A equals square brackets 1, 2, 3, that's an object. When you create a string, that's an object. When you create an integer, a float, in Python, actually, everything is an object, meaning that it has a particular data type. It knows what kinds of functions you're allowed to use with them. It knows exactly how to organize the data that you pass to them. So that's the kind of, that's the notion of an object in object-oriented programming. And Python, in Python, we use a lot of these OOP-style programming, but it doesn't mean that Python is only supports that. Python supports functional programming, OOP, but this is the kind of the most intuitive way, at least in my opinion, of programming. And the importance of this topic is that as we go along in MDS and you take a lot of other courses like machine learning courses, like visualization courses, data analysis courses, everything that you see, everything that you'll do, you'll be using the concept of objects, the concept of classes and data types. So this is a very, very important topic. Also in the next course, for those who will take 512 with me or take another algorithms and data structures course, you will be defining your own objects in order to implement particular algorithms and particular types of data structures. So this session, I think, is the most important session of this course, and I think this is also one of the cornerstones of your programming skills, basically. So let's dive right into it. All right. Okay, so suppose that I want to save the information about an instructor in the MDS program like myself inside of a data type in Python. So I might use something like this over here. I might use a dictionary like this, and because it has key value pairs, I say, okay, first name is that, last name is that, email is that, and it's very easy to access those values using those keys. It's not like a list. List would probably not be an appropriate data type for this case because you have to remember what index stands for which value. So, okay, we choose this dictionary to be our data storage type, basically. Now, suppose that there are some certain types of operations that we want to be able to do within our program with this particular organization of our data. For example, suppose that I want to have a function that concatenates the first name and the last name in order to give us a full name, okay? And in that case, I can do something like this. Okay, so I define a function, and then inside of that function I take two arguments, first and last, and then okay, it returns a formatted string. The first string here is the first name, the second one is the last name separated by a space, and this is the particular way that I define it. You can define it however you like, but this is usually the format. Okay, now if I want to concatenate the first name and the last name stored within this particular data over here, what I should call is I have to call the full name function on those first and last names stored in MDS_1. And this gives us something like this. So this is the first argument, this is the second argument, and if we run this code from the top, we will get, okay, the first name and last name concatenated together. All right. And now we can create another data for someone else in MDS program, Tiffany, for example, who's not here with us this year. Okay, so now I created an object to store the information about another instructor, and I have to repeat the same thing for all other instructors as well. Now this, when you have a lot of these kinds of data and a lot of functions in your code, this becomes very messy very soon. So for example, suppose that you have a long code file, and inside of that code file, you don't only have functions related to that particular data, you also have tens of other functions that take in other data types and are maybe completely irrelevant to this particular data that you have. But you need them to be inside of that file for some reason, or inside of that directory for some reason. So it becomes hard to find which function applied to which data. You have to go through the documentation, and yeah, and it gets very messy. So the concept of object-oriented programming helps a lot with this. So we want to package together the data and the functions pertaining to a particular data type together all in one place. Okay, let's see how we can do that. So what is a class? The way that you define an object, the way that you define how the data is organized, how the functions are defined, what kind of functions are defined for a particular data type, can be done using the concept of defining a class in Python. So just as you have functions in order to define actions and operations, you have the concept of a class which defines what an object should look like, what kind of functions are there for this object, and so on and so forth. Okay, so basically they say that a class is a blueprint, meaning that it's like a design, a kind of map or something for creating the object. Okay, let's see how we can create the blueprint for an object. So it's done with the keyword class, followed by the class name. So in this case, I want to create an object that stores information about MDS instructors and also the kind of functions that I want to embed in that particular data type. So I'll say MDS member, and then here I'm going to say pass, meaning that I don't want to do anything with this right now, but I'll add other statements to it later. Okay, so this is how we define a class, and now if I type MDS member, it recognizes that as something defined in my Python code. Okay, now let me create an object using this blueprint. And the way that I create an object using this blueprint is very, very similar to what you have been doing so far all along. So, for example, if you want to create a list, you do something like that, right? Okay. Now, for classes that we define, it's just a tiny bit different. So for a list, you can also say list, then 1, 2, 3, something like that. Yeah, something like that. And then it defines the object for you, right? And it's basically the same thing for our own objects too. So I can define MDS1. This is just a name that I'm giving to my variable, and I want it to be a member of this class. Okay? So now, if I run this, MDS1, okay, it tells us this particular variable belongs to the MDS member class, which resides inside of this module. You don't have to worry about that, but just see that this belongs to this particular class. Okay? Now, this object is not very useful because we haven't defined anything inside of it, but soon we will do that. Okay, now let's start with the most important part of defining an object. So when we do this, when we define a variable using our class, we want to create an object, we want to do some operations as soon as the object is created. For example, with a list, we pass some arguments to that list, we pass the data in, and we want that data to be stored inside of that object, right? That's the first thing that we want to do. With this particular class that we have here, for example, what we want to do is to create a variable called first, and then assign it something coming from the argument, and then assign another variable called last, okay, and then something like email, okay? And this is not exactly how it works for classes. What we have to do is that we have to wrap all of that inside of a particular function inside of our class. And that particular function is called def __ init. Okay, and here I have to say self. And the syntax looks cryptic at this point, but bear with me. You're gonna know what's it all about in a few steps ahead. Okay, so now, as soon as we want to assign that object here to a particular variable that I'm creating, Python calls this init function. Okay, so the first thing it does, it calls that function, and it's already defined in Python. This is how Python works. This is how it's designed. Okay, and here we can define whatever we want to do as soon as the object is created. Okay, so what I want to do is to define these variables, right? And I want to store it inside of this particular variable that I'm creating. Okay, now let's see how we can do that. Let me erase that. And then here, I'm adding self, but we'll learn what this means. And here, I'm adding arguments first and last. Okay, first and last. And for now, I'm gonna get rid of this email. Okay, now let's see what all this means here. A little bit on the terminology here. So far, whenever we create some data in Python, we call it a variable, okay? And also we call whatever's defined inside of a def, we call it a function, okay? In classes, we call variables, sometimes we call them attributes, and also we call functions methods. This is why I have been referring to those like list.append, a method, or string.lower, a method. In OOP, in object-oriented programming, this is the terminology that people use, and you'll get used to it if you start reading documentation for Python or any other programming language that supports this. Okay, so here what I'm defining is certain attributes or just variables, and I'm assigning it to the particular object that I'm creating. So this self stands for this particular object that I'm creating here. Okay, so Python automatically, when we create this variable, Python automatically knows what this is and assigns a reference to that and passes it to our class. So here, when I take in a first name, for example, Arman, and then a last name, okay, what Python does, it grabs these two arguments, okay, and saves it inside of the first and last attributes of MDS_1. Okay, let's do that. Let's see how it works. Okay, now if I type MDS1 and type dot, I can see these two attributes showing up. Okay, and if I inspect those, okay, so I'll get my attributes back. All right. Okay, so now how is it different from doing something like this? First equals some value, okay? For example, Okay. The difference is that in the way that I have defined here, these two attributes, this data only belongs to MDS_1. Okay. Just as in, for example, if I define a list here and call it something 1, 2, 3, something like that, these 1, 2, 3 only belongs to a_list. It doesn't belong to all lists. Okay. So this is the difference here, and that is implemented using that self. So self refers to the object itself. Okay? And when you call the method or when you set attributes, you don't have to refer to self again. So you just use it when you're defining methods inside of the class. I know there's a lot of words being thrown at you at the moment that you might not be familiar with, but you'll get used to it, don't worry. Yes?
Yeah, so I wonder if there's a way to define the type, so give a type hint for the variable inside the classes.
Give a type?
Give a type, the hint of the type.
Oh, yeah, question is if we can give a hint for the type inside of a class. So it basically works in exactly the same way as we do for other functions. So for example, I can here add a colon and say stir, and then colon and stir. And again, it doesn't do anything with the execution of the code. It's just a hint to the user or for yourself that this is going to be stir. But just to clean up, make the code more cleaner at this point, and not to distract you, I'm getting rid of them right now. Okay, so before moving on, any questions about this? Yes? Yes, exactly, because like any other function that you define in Python, if these are required arguments, meaning that they don't have any default value, so order matters. Okay. Yes?
Is it common practice to define functions within classes?
Question, is it common practice to define functions within classes? Yes, if you're creating a particular data structure for your purpose, and that particular function really belongs to that particular data type, this is something that you want to do with that data type, it's in OOP, you have to embed it within your class. Yeah. Question? For first and last? Yes. So question is, can we set default values for first and last? Yes. Just like any other function in Python, we can have default values for those. And we can try that. So let's say U BC. Okay. And here, if I don't supply any arguments, and here I call first, and then you can see U and last BC. Okay? All right. Any other question? Yes?
You have two different initializers depending on what kind of object.
Okay, question. Can we have two different initializers based on what kind of input that we're using? Yes, we will get to that towards the end of this lecture, but that's a bit more advanced than what we usually do. Yes, question? Yeah, good question. So can we use the built-in functions inside of the class? So within a class, it's just Python code. You can do whatever you like. You can do whatever data type that's already created, either by you or if it comes built in Python, you can use whatever you like inside of your class. So it's basically just another piece of code that Python recognizes to be the blueprint for an object. Okay, let's move on. Yeah, sure. If you don't do that? Okay, so Python doesn't give you an error, but the problem is when you create your object here like MDS member, then you haven't stored anything inside of your object, right? You should then later on add attributes to it. You can do that, but when you initialize that object, you haven't defined any data.
And the second question is that the difference between initializing through this method and then having another variable, say first equal to some name.
Yeah.
Is that this variable just belongs to this particular object?
Yes. Yes.
But the other variable is also within the class, like it is defined within the class. It belongs to the same class. Yeah, good question. We'll get to that. But what I defined firstly above the init
function, it's called a class variable, meaning that for all of the objects inside of that class, if you look at that particular variable, you'll find the same variable, the same value. However, with regular attributes that you define with self, that data is only specific to that particular object that you have created. Just like, again, just like lists, tuples, when you create a list with some values and another list with other values, those two sets of data do not interfere with each other. Each one belongs to its own object. Okay. All right, so let's add another attribute here called self.email, and this is something that I want to construct myself. Okay, the way that I construct it is that I take the first and last name, add a dot in between, and then lowercase everything, and then add at ubc.ca. Okay, and note that this is not something that I take in as an argument. This is just something that I define using the data that I have received. So you're not only limited to the data that you receive from the arguments. You can define whatever you like inside of that initialization function, and then it will be assigned to that particular object. Okay, now let's run the class again. And here I'm going to have this MDS member. All right, now if I query the first name, for example, first MDS1 first. Yeah, that works. And now let's query email. And okay, this works fine. So you can see when the object was created, and again in programming terms, they call it when the object is instantiated. You're going to hear that in documentation and in other places. So when the object is instantiated or created, these two arguments are stored inside of the object's first attribute and last attribute, and there's another attribute is created called email, and then inside of that we do some particular other operation with that data that we receive. Yes?
Does the MDS member class stores or other information somewhere?
You mean the class itself? Yeah. No. The data is stored inside of this particular object. So as soon as you do this, you do MDS_1 equals MDS member, then Python assigns a particular place inside of computer's memory and assigns it to this particular object. And because we have defined the class, it knows exactly how to fill in the values that you like. Okay? When you have defined this blueprint, Python already knows that there's going to be a first attribute, a last attribute, and an email attribute. So it exactly assigns a particular location in memory, assigns particular space for those three variables, and then it already knows what to do with that. Okay. Yes?
We're limited about the processes that we can do or do not inside the class in Python.
So question is, what kind of processes that we want to do? We are limited to do? We are not limited to do anything. We're not limited by anything, basically. It's, again, just plain Python code. You can do whatever you like. Okay. All right, now comes the time. So this is just to create the object, basically to initialize our object. Now comes the time that we can actually embed functions that belong to this particular class, as we call them methods. So we can add particular methods that are special to this MDS member class. Okay, so here we've seen that we had a function called full name that we used in order to process this data that we had here. Okay, in some particular way. Now, let's bundle that together with other functions and attributes inside of MDS member. So the way that we do that is basically just as we define any other function inside of Python with one difference. So the difference is that whatever method we define inside of a class, we have to, not every method, but most methods take in an argument called self, again, which refers to the object that we're creating. Okay, so here I'm creating full name. It takes in self, meaning that look at the object that I'm creating right now. Okay, take its first attribute, take its last attribute, and do this particular thing with it. Okay, it means that it looks, for example, here, it looks as it grabs this particular word and this particular word here. It doesn't grab like some other random word. Okay, so self refers to that. It means that look at the object itself, grab its data, and then do this operation with it. Okay, let's redefine the class again. And then, now let me run full name. And as soon as you define that, you can see that when you type dot, full name appears. And this dot notation in Python is the way that Python defines its syntax to access attributes and methods belonging to particular objects. So by this point, you have used string.lower. .lower is a method inside of the string class. Okay? Now let's run this. And yeah, it does the same thing as we expect it to. Okay. Any questions? Yes?
Is it common to add documents to functions in your objects?
Question, is it common to add doc strings to functions within classes? Yes, just like any other function, we have to add when we want to develop code that is usable for others, we have to add doc strings to our methods just as well as we do the same thing for functions. Okay. Yes?
So, can we define methods as functions within specific classes?
Can we redefine methods as functions? What do you mean by that? Can you elaborate?
Because I'm just saying for methods, we are calling some functions, right?
Mm-hmm.
Within the class.
Right.
So those methods are specific to
That object, yes, yes, yeah. Do you mean that we can, whether we can pass objects to other functions? Is that the question? Like passing, we have created MDS1 object. Do you mean that whether it's possible to pass this object to like some other function defined inside of Python? Is that the case? Yes. Again, just like any other function that, for example, we create a function and we take in a list and then we process it in some way, that list is an object and we have passed it into a function that we have defined. And the function doesn't belong to any object. It's just a free function. Yes, that's absolutely possible. Okay, so now let's create some other data with our code here, with our object here, to show you something about class attributes. Okay, so here I'm defining two instructors in MDS, and here I'm going to add a variable here at the top. So I'm going to say role equals MDS member. Okay, role. All right, let's define this. And now if I type MDS1 and say role, I see MDS member. Okay, and if I type MDS2, okay, that's Joel, and type role, again I see MDS member. So just like I said, class variables or class attributes belong to all of the objects in a class. Suppose that, for example, you want to define the number pi, and you're writing code to do some mathematical processing. And pi doesn't depend on the particular object you're working with. It's a constant. So you may want to define it as a class variable so that it's the same for all of the objects that you create using that particular class. Okay, so you can see that there's no self here. This means that it's the same for all objects regardless of what the object is. Okay, again, terminology. So this is a class attribute. Okay, and we call these instance attribute. Okay, an instance means this variable that we have created. We will call this an instance of the MDS member class. This is an instance. This is an example of the MDS member class. Okay, this is just one particular let's say representation of that object. Okay, so if we want to draw an analogy to real world, it would be like, so a car company builds cars with the same model and the same color with the same model, but they come in different colors. They come with different types of engines. They come with different types of options, but they're all the same car. So the model is the same, but their attributes, like their color and the options, are different. That's actually quite like the notion of the class here. Okay. So, any questions? Oh, okay, yes. Mm-hmm. So, question is, do we not have to pass email as an argument to init? That's the question. Yeah, we don't have to do that because we don't want to receive that from outside. We want to create that based on the input that we receive. Yeah. One other question. Yeah. You have to speak up, I can't hear you. A default initialization for objects? Yes, you can just get rid of the init and it will create an object in memory for you for that class, but it doesn't have any attribute or any function or anything. Yeah. So it gets created, but there's nothing for it. Nothing is created for that particular object at the moment of creation. Yes? Oh, okay, good point. Is it standard practice to capitalize class names? Yes, we'll learn about that in next lecture for when we talk about style. But basically, we want to capitalize the name of classes, or if there are several words, we want to capitalize all of them. Okay. Sorry, we have to move on. Sorry. Okay. So, now let's go ahead and talk about another particular type of method. So we have learned about this special method over here, underscore, underscore, init, underscore, underscore. These are called dunder methods, which is short for double underscore methods. And these are special functions. These are designed by Python developers to do some particular operations. They have a special design, and for example, init is always called when the object is created, and we have several others like this one. Okay, so these are dunder methods, and we have several of them. And this is called an instance method, meaning that it belongs to a particular instance of the class. For example, it acts on this particular instance or this one because it takes self, and it can receive data from that particular object. Okay, now we're gonna define another type of function which is called a class method. What is a class method? So suppose that we want to have an alternative way of defining our class. Okay, for example, suppose that, so right now my function, my class only works if I pass the first and last name passed as arguments separated by a comma, right? But now let's suppose that we want to accommodate the fact that some users might be interested in inputting the name as like first name, comma, last name as a single argument. We want to accommodate that. Okay, so basically we want to create an alternative way to create our object. That's done by defining an alternative constructor for our object or initializer. So suppose that I want to call this from CSV, meaning from comma separated value. Okay? And here I take in CSV name, which is something like this. For example, okay, I want to be able to create the object even with this single argument over here. Okay. And now here I say first, last, CSV name dot split. Okay, and as soon as I do that, now I have separated those two words, and now I can pass it as usual to the init function, right? Now it's separated, it's two arguments, I can pass it as usual to my initializer. Okay, so the way that we can do that is that we have to return the initializer from the class. The syntax is complicated, I agree with you, but this is how we do it. So CLS first, and I'm going to explain what this means. And here just like self, we pass in CLS. Okay, first, last. Okay. Here we have to add class method. Yeah. Okay, now what it does is that when I want to create my class, instead of just calling it like this that I have done, I can also do something like this from CSV. And here I can pass a value like that. Okay? And it still understands. This particular way of passing this value to the class. Now, where does it come in handy? In the next lectures, we're going to talk about like NumPy or Pandas. These are packages for data analysis. And with these packages, when you read files from your hard drive, sometimes your files are formatted as CSV files. Sometimes they're just plain text files with white spaces. Sometimes they're binary files. Okay, so with those packages, for example, we want to be able to accommodate several different type of files in order to create an object for us inside of Python. So that's where it comes in handy. So we want to have several different ways, or maybe just 2 different ways to create your object. Okay, so let's now MDS member. Okay, and let me call it MDS3 so that to see that this is actually working. We have to run this and then, okay, so MDS3. And now first and last. Okay, it seems like it's working. Now let me define the syntax here for you. So the syntax is that when we write this @class method, Python recognizes this as a particular function, and we call that @sign something, that we call it a decorator in Python. I have notes in the lecture notes for you about decorators. This is not necessary for you. Just know that a decorator modifies the behavior of a function in Python. Okay. Sometimes you want to time how long a function takes to execute, and you decorate it with @timeIt, for example. It just runs the function and returns to you the time as well as the output of the function itself. So it's just something that modifies the behavior of the function. Okay, so now Python recognizes that this function is an alternative way to construct your object. And CLS here stands for the class itself. Okay, so that's the first default argument, just like self. And we process the input in the same way that we like. And then once we processed it, we can now pass it to the class itself just like we normally do. Okay, so CLS stands for this particular class. And the way that we define it using the init method is that we take in 2 arguments. Okay, so we say that, okay, we have received this string, we have processed it, now we're ready to make the object using the class in the usual way. Okay, this is all a bit, I mean, it sounds complicated, and it can be, but it takes time and practice to get used to the syntax. But don't worry, you'll get used to it. Don't worry about that. It's normal to feel lost in the beginning when we define these concepts, especially if you haven't seen them before. But you'll get used to that. Okay, so we're at the 40 minutes mark here. Let's take a break of maybe 4 or 5 minutes, and then we'll come back. I'll also walk around. If you have questions, you can ask me. Spencer, you had an where's Spencer? Yeah, you had an announcement to make.
Thanks. Yeah, big announcement. Break is perfect time, if you haven't already, to do the feedback survey. Posted in the students only channel of Slack, super secret channel. So takes like 5 minutes, perfect break time activity. So that's all I wanted to say.
Chairman, I have some question regarding this one.
Okay, now let's just quickly talk about one last type of method inside of a class, and that's what's called a static method. A static method is nothing but a regular function. It doesn't take in self or anything. It's just a helper function that you think is better to be bundled inside of that class. So nothing special. It's just a helper, and then you define it using this static method. Okay, and def here, and suppose that the function that I want to define is this. Okay, is quiz week. So if it's the week number is 3 or 5, it returns true. If not, it returns false. And you can see that it doesn't take in the object argument self. It's just a helper function that you might use within your class. So this function could have been outside of this class just because it probably is related to whatever you're doing inside of the class. You're preferring to bundle it together with other things inside of your class, package it together inside of your class. So static method, again, doesn't take any object as argument. It's just a helper function that you prefer for it to be included in the class. Okay, if I run this, let me just show you a quick example. And then you can run it like any other function, with the difference that it's available from any method. So I'm going to create MDS1 here, and then MDS1.isQuizWeek, and then I'm going to pass 3. It says true. So you can see that it's just a function that's packaged inside of the class. Okay, so again, with this decorator static method, we can modify the behavior of the function. Here, the class method tells Python this is an alternative way to construct your object. Here, static method tells Python that, okay, this is just another function that I prefer to include inside of the class. All right, so let's move on to the next topic, and that's the topic of inheritance. So whenever we define classes, sometimes we define something like a base class, meaning that we create the class for an object that has some basic functionalities, and then we then want to create an object that basically extends that particular base class with more options, with more functionality, with more things to do. So the way that we can achieve this is with the concept of inheritance, meaning that a child class inherits everything from the parent class, but it can also add its own functionality, its own data structures, its own methods, and everything else that is definable for inside of a function. So let's see how that works. Okay, so once again, we have our MDS member class here. Okay, just as before. And now suppose that I want to create an MDS student class. Okay, so the way I do that is by typing MDS student, and here inside of these parentheses, I have MDS member. I'm going to pass on this right now, but note that with the base class, we didn't have any arguments. But here, I have an argument. It means that this MDS student class is based on this MDS member class. So even though this function right now, this class is empty, it still inherits all of the functions, methods, and data structures from the parent class. Okay? For example, let me create this particular student here. Okay, so student 1, MDS student, it refers to this class, but this class is a child of another class. Let me define that. It's because I haven't run this one. Okay. So, this ran successfully. Now, although this class itself is empty, I still have access to all of the methods inside of my other class. So full name, for example. Okay, if I type that, run that, and it returns the full name of that particular student. Okay, so it inherits all of the functionalities from the parent class. And we also have access to all of its attributes and everything else. For example, first, and it returns the first, although the class itself is empty. Okay. Now suppose that I add a class variable called role, an MDS student. Okay, remove this. And now if I run that, because this is special to this class, if I run role, this will give me MDS student. However, at the top for MDS itself, we had role MDS member. So this means that whenever you define a child class and it inherits from a parent class, if you define the same methods or the same attributes, it's going to overwrite the attributes and methods coming from the parent class. It's going to overwrite them if they have the same name. Otherwise, they will be kept as they are, and we add other extra functionality. Okay. All right, so now consider the scenario that we want to define an object with the MDS student class. However, an MDS member just took in two arguments, first name and last name. But let's say for a student, we also want to have an argument called grade. Okay, so first name, last name, and grade. Okay, it's silly, but just to show you an example of how it works. Okay, so in this case, I can actually have a separate init method for this one over here. Okay, and do something like this. Init, and just ignore that for a second. So self, just as usual, first, last, and now I'm going to add grade. Okay? All right. So in order for this class to still be constructed using the same method as the parent class, but add another argument on top of that, I can do something like this. So this is a particular syntax. I call super, open close parentheses, init, and then first and last. I'm going to explain this in a second. Self grade equals grade. Now let's demystify what this is. So super in Python refers to the super class or the parent class. Whenever you call super, Python looks at this class and finds its parent, goes to the parent, and when you type dots, it refers to the methods and attributes of that parent class. So here, I tell Python, whenever you want to construct this MDS student object, please refer to the parent object, to the parent class, and read its initialization method. And we know that it took only two arguments. Sure, no problem. And then, using this additional argument that I'm taking for MDS student, this additional argument, define a new attribute, like grade, and assign it to self.grade. Okay. So now, with this new syntax, let's create this student object. So you can see that I've added John, Smith, and B+ as the grade. All right, now, when I do that, you can see that the object is created, and now I can refer to grade, because this is a student object. So basically, we have called the constructor from the parent class. Okay, first and last name, that's all good. We want that still. But we want to add another argument too, because this is a student. It has other attributes that we want to take in as data. Okay, and define that within that class. Okay, so this is how inheritance basically works. We have access to everything from the parent class, and we can overwrite them if we want, and we can also extend those classes. This is something that happens a lot. So, for example, you have a package, it defines a particular object, like in pandas, you have the data frame object, which just a table, okay? And suppose that there's a particular functionality that you need that pandas doesn't offer. So basically, you can define your own class, inherit from pandas, and then extend it just the way that you like. And that gives you a new object. It has all the options and functionalities of the parent class and something added on top of it. Okay? And I'm going to show you an example, a cool example here of how this extension works. We have the tuple object in Python, right? The tuple is just like a list with the difference that you cannot change it. Okay? So, how do we define a tuple? Let's do that here. Suppose that I say tuple 1 equals 1, 2, 3, 4, 5. And tuple 1. Okay, so that's a tuple. If I type dots here, I can see that we have basically two methods. So this is something also interesting. When you type dot, you see all these special methods over here. And now you know what these special methods mean. These are the methods inside of the tuple class that have been defined for particular purposes, and I'm going to tell you an example of one or two of them. Okay? So now you know how this whole thing actually works. Okay, so we have two methods, count and index. All right, suppose that I want to have my own tuple object. For a particular application, I want to be able to compute the mean, okay, the average of all the values inside of the tuple. Okay, it doesn't have such a method inside of it. And suppose that I don't want to create my own function mean and apply it onto the object. No, I just want to extend it. So I'm going to extend the base Python class here. So class, let's call it my tuple. Okay. And I'm going to inherit from Python's built-in tuple because I still want to have all of what tuple offers, but I want to extend that. Okay? So for its extension, I'm going to define a method called mean. It takes self, the object itself. Okay? What I want to return is the average value. So let's say AVG, or AVG. And the way that I do this is that I can create a list I for I in self, because self is a tuple, I can iterate through that. And with the list comprehension, I can create a list out of that. And then there's a built-in Python function called sum, which operates on lists, and then divided by the length of self. Okay, and now return average. All good. So tuple, let me redefine this thing over here. Okay, now tuple 1. And now, let me see, tuple. Okay, so I have to call my own tuple here. And let's say 1, 2, 3, 4, 5, tuple 1. And now if you type tuple 1, you can see that my method appears on top of what Python has for tuples. Okay, mean. And the mean is returned to me. Yes?
What's the difference between the functions you show there and the functions you show with the two underscores on the other side?
Oh, okay. So these functions that we define just like regular functions are methods for that particular class. However, the double underscore methods, dunder methods, they have specific interpretations. So when Python sees the dunder methods, it interprets them in a particular way. For example, when it sees dunder init, it knows that it has to call it whenever the object is created. Okay, so they are special methods. Python knows how to deal with them in a particular way. Yeah. Okay. Question. Mm-hmm. Yeah. For class method, for add class method, for each method you have to prepend it with add class method. Yeah. You can define it wherever you like, but it has to be prepended by that add class method. Okay. So here it's a cool example. We have added some functionality on top of what Python offers us, and this is the concept of inheritance, a nice example of the concept of inheritance. You have everything you had before, but you extend it by inheriting from the parent class. Okay, now I'm going to quickly talk about two other special dunder methods, which again shows a very cool example of the kind of things that you can do with Python objects. So let's suppose that I want to define an object called bank, and inside of that bank, it's a particular data structure that I need. Inside of that bank, I want to hold particular currencies, for example, USD, CAD, and euros. So I want to hold particular amounts of these currencies. Okay, so class bank, I'm not going to inherit from anything. Def init. When I create it, I take in self, and when I create my bank object, I want to be able to give it USD values, CAD values, and let's suppose euro values. Okay, and as soon as the object is created, I want these to be assigned to the object USD attribute, and that should be equal to USD. Self.CAD, want it to be equal to the argument that we receive, and here self.euro, and again I want it to be equal to the argument that we receive. Okay, as simple as that. Nothing fancy here. Okay, let's define that class, and now I'm gonna type bank1 equals bank, and I have to provide values, so let's say 10, 20, and 30. Okay, that's the first bank, second bank, and suppose that's 0, 0, and 122.2. These are pretty small banks, by the way. Yeah, so, okay. All right, the banks are defined. So now what I want to do, okay, we remember we can add numbers together, we can add strings together, so why not adding these two banks together? Okay, it says unsupported operand for the plus bank and bank. What it means, what Python wants to tell us is that I don't know what to do when you tell me to add two banks together. It doesn't know. For integers, it knows. For lists, it knows. It might not be the same kind of operation that you expect. For example, it just concatenates them, okay? But for this particular object, because we created, it doesn't know what to do with it. Okay, there's a special dunder method that comes with Python called def__add. Okay. And this add method basically tells Python what to do when Python sees the plus operator between the bank object and another object. Isn't that cool? So whenever it sees the plus sign, now it knows because we can define it for it how to interpret that plus sign. Okay, so I'm going to do this, self and other. We say that whenever you see this, return another bank, which basically does this, self.usd plus other.usd. And you basically see the pattern here. CAD plus other.CAD. And finally self.euro plus other.euro. All right. Now I redefined this, and now let's run this thing again. And when we run this, yeah, we don't see any value because we haven't assigned it to anything. So let's see some bank here, okay? And now if I look at some bank and look at its, let's say USD value, it says 10 because I added 10 to 0, so this wasn't a really good example. But 30, oh sorry, but euro. Okay, now Python knows exactly how to interpret that plus sign. And we have a bunch of such special methods. Here they are. Addition, subtraction, multiplication, division. You can incorporate whatever functionality you like for those operators that we have in Python with these special dunder methods. You just define it the way that you like, and then you have that capability. This concept is called overloading. So this plus operator means something in mathematics. Then you overload it with other stuff, with other functionalities. Okay, so this is called operator overloading. And there are like a bunch of such methods in the Python documentation. You can explore them in detail if you want. Okay. One other example, just to quickly show you another way, another special dunder method. Okay, so if I do something like this, is bank 1 equal to bank 2? Okay, so maybe I should get rid of this. Okay, just a second. Okay, yeah, that equality behaves, I don't know why it still remains in my environment, but let me redefine that here just to show you how it works. So there's another special Dunder method called EQ Dunder, and again, it takes self and other. Other stands for the other object. And then what we can do here is to return a Boolean. So whenever Python sees that equal sign, it knows how to interpret that. So here, I'm going to say if self.usd equals equals other.usd, okay, I want to return true. Okay, and else return false. Okay, bank 1, bank 2 hopefully says false. Yeah. And now let me do this, and now it says true. So whenever the USD values are equal, it says true. Whenever it doesn't, it's not equal. Regardless of whether these values are also equal, it would say false. So this is just another example of a special Dunder method. Okay, and there's a lot for you to explore in there. All right, so let me see if there's anything else to cover here. No. So before jumping into the next topic, which is about testing and debugging, and we're going to have a short introduction on that, let's take 2 questions. Yes?
Here you have the keyword self and other.
Yeah.
That is to take like 2 arguments. Like in case you had say 3 banks, then what is the keyword for?
Yeah, so when you have three objects being added together, like a pair of them is getting added together first, and then that will be added to the result of that. So you will never have that problem of 3 arguments. Yeah. One other question. Yes?
How are we making sure other is not something else?
Oh, good question. How do we make sure other is not something else? So if other is something else, then other.usd doesn't mean anything, it doesn't exist. Then we will get an error. Okay? So it depends on what kind of object you want to add to your current bank object. So if you want to accommodate using integers and floats, then you have to do something else. You have to remove that .usd, and then it works. Okay? Very good question. All right. So this was an overview of the concept of classes. Of course, with just a 1-hour lecture, you're not going to master it, but with practice, as we go through the labs, and the remaining of this course and most other courses in MDS, you'll get pretty much used to it for as much as you like to be able to use the concept of classes. And for this year, I recreated the entire lab too, in order to focus a lot on these special methods, classes, and I tried my best for it to be something that you can learn a lot from for the concept of classes. So I hope that's something that you will enjoy working on. Okay, let's jump into the next topic, and that is the topic of debugging. So taking a break from all these little bit convoluted concepts of classes and everything. So let me show you a couple of nice ways in order for you to be able to test your code and debug your code. So far, you have seen statements like this in your autograder. Assert something. So this assert statement is a statement in Python that basically doesn't do anything if the statement in front of it returns true, but if it returns false, it's going to complain. Okay, so this is something I use within the autograder, whenever your solution does not give the expected output, I do one of these asserts, the assert returns false, and then we get an error. Let's see how it works. 1 equals 2, and then it says assertion error, meaning that you wanted to assert something, you wanted to make sure something is true, but it's not. Okay, and it also takes in a message, so you can say 1 is not equal to 2. Okay, and then it shows this message in front of the assertion error. Okay, so this is one way to something to put into your code, and whenever you get that particular error message, you're going to know, oh, it comes from that particular assertion that I have put in my code somewhere. Okay, so this is one way to make sure that your code is working properly or where it doesn't work properly. Okay. All right, so just a few definitions when it comes to testing functions and debugging. So you're going to hear the concept of unit tests. And unit test means that we want to break our code apart into several different pieces defined in functions. Each function is supposed to do a particular limited kind of operation, and we want to limit what the function does in order to be able to test it efficiently. So the concept of unit testing, again, comes down to breaking apart your code into several different functions and then examine each unit through tests. So tests can be implemented in various ways. There are Python packages in order to do this, but basically you can write your own testing functions. For example, if this function returns this, then assert this. If not, then write an error message. But testing is a whole topic by itself. You're going to learn a lot more about this in one of your future MDS courses. I don't remember exactly the course's code, but there is a course coming up about that, at least for MDS Vancouver students, that talks in detail about testing, modularizing your code, packaging your code, and all the stuff that surrounds that. Okay, now let's quickly discuss something very, very useful for you when you write code, debugging. Okay, so when it comes to debugging code, what is the first thing that you do in order to find where some particular error happened, what the values are? Are they the values that you expect or not? What is one thing that you probably have been doing so far? Yeah, exactly. I do it all the time myself. So we print stuff, okay? I go into a loop, print I so that we know what I is, print list so that we know what the content is. That's a very manual way. It works for simple, short code. However, if you have large code bases, you have 100 functions and classes, and then it gets pretty messy pretty quickly. So with those situations, we want to have a more robust way of debugging our code. And I'm going to show you how you can do that inside of VS Code. So most of IDEs, like VS Code or JupyterLab, they have a visual debugger. There are also command line debuggers, but I don't prefer them for my use cases. You might, but the visual debugger is much easier to use. So let me show you an example of the VS Code debugger over here. So I'm going to copy this code that I have from the random walker function from the first assignment. Okay. I'm going to need this. Okay, so this random walker, when I print the values, you might notice that the x-coordinate never becomes positive. So if I keep running the code, it just never becomes positive. So there's clearly something wrong, and you might see it right away in the code. What do you think the problem is? Yeah, so the if statement, each one of these if statements covers several cases. For example, if a value is smaller than 0.75, if a value is smaller than 0.25, it's also smaller than 0.5, it's also smaller than 75, so all of those statements get executed, and that's not the right way. We have to use elif. But suppose that we don't know that. So the way that I can launch a debugger inside of VS Code is that I have to use this button over here called debug cell, okay? But before that, the way that we use a debugger is that we say points in our code that we want the execution to be stopped and then look at the code, okay? So those points are called breakpoints. And in VS Code, if you put your mouse put your cursor right besides the code here on the gutter, what's called the gutter, the borderline over here for the window, you can set a breakpoint. Suppose that I set a breakpoint right here, okay, and one other here, and maybe one other here, okay. And then, now if I run debug cell, okay, the whole window changes and something new comes up. I have this orange here, this orange status bar that tells me something is going on. Okay, so we have run our code. As soon as the debugger encounters one of those breakpoints, it stops. Now it's time for you to see what's going on with your debugger. So you can immediately say in the variables window, it says t equals 5. And t is the argument to this function that I have provided here. Okay, t equals 5. All right, I guess I have a number of buttons over here. One says step over. So step over basically means go to the next line. Okay, let me go to the next line and closely watch this window, this side pane over here. Step over. X becomes equal to 0. Oh, okay. Now, step over. I'm in the loop. Y also becomes equal to 0. Okay. When the line is yellow, that line hasn't been executed yet. And as soon as I click that, you can see rand becomes equal to this. Okay. Now the random value is smaller than, the random value is 0.77. So will this line be executed? No. So we step over that. Will this line be executed? No. Okay, this one, no. So we go to the else and y becomes decremented. Look at the y. It becomes -1. Okay? And now the print is going to be executed. Step over, one print. We go back to the top of the loop. And then we go through that and we can inspect the values changing over here, and that gives us a very, very interesting way to look at what we have. So you can ignore this call stack here. And here is another tool for us to basically watch a certain expression. It's very cool that you can define your own expression, something that's not defined in the code. Because, for example, let's say I want to look at the value of the random, but I want to format it in a particular way. So rand.toF. I want to watch this expression as the code goes through its execution. Okay, step over that. Let me go back to random and see how the expression here changes. Okay, 80.86. So you can watch expression, for example, slices of lists is an example, or the value of a particular function, or whatever you like that can be expressed as a statement. For example, I can have this expression over here, okay, and then look at the value there, 1.0, and then it becomes 2. So I can watch as many expressions as I like in addition to the values that I have over here. There are a couple of other buttons. This button, this play button, runs your code until it reaches